Peanut butter is a staple in kitchens worldwide, valued for its rich flavor, versatility, and nutritional benefits. Whether spread on bread, blended into recipes, or eaten straight from the jar, it's a product millions rely on daily. But how exactly is peanut butter made on an industrial scale? Today, we're taking you inside a peanut butter factory to review every step of the production process, from raw peanuts to the sealed jars you find on store shelves. This is a detailed, no-nonsense look at the machines, techniques, and quality controls that transform this simple crop into a global favorite. Expect precise insights, surprising facts, and a clear breakdown of each stage, all delivered at a fast pace to keep you engaged. Let's get started with the journey from field to factory. Peanut butter production begins in agricultural fields, where peanuts are grown. Peanuts, technically legumes rather than nuts, grow underground in pods attached to the roots of the plants. Each pod typically contains 2 to 3 peanuts, and a single plant can yield dozens of pods. Globally, over 50 million tons of peanuts are produced annually, with China leading at approximately 20 million tons, followed by India, Nigeria, and the United States. Farmers plant peanut seeds in well-drained sandy soil, typically between April and June, depending on the region. The plants require 120 to 150 days to mature, with irrigation and pest control ensuring optimal growth. Soil is tested for pH levels, ideally between 5.8 and 6.2, to maximize yield. Once mature, the peanuts are harvested using specialized equipment, marking the first step toward the factory. Harvesting is a mechanical process designed for efficiency and scale. A machine called a peanut digger moves through the fields, equipped with blades that cut into the soil to a depth of about 6 inches. These blades loosen the plants, lifting them from the ground and inverting them so the pods are exposed to air. The inverted plants are left in the field for 2 to 5 days to dry naturally, reducing the moisture content of the peanuts from around 40% to 10 to 15%. This drying is critical, as high moisture levels can lead to mold or spoilage. After drying, a combine harvester, fitted with a pickup mechanism, collects the plants. It separates the peanuts from the vines using rotating drums and sieves, depositing the pods into a hopper. The vines are often returned to the field as organic matter or used as animal feed. A single combine can process up to 10 acres per day, collecting thousands of pounds of peanuts. These harvested peanuts are then transported to the factory in bulk trailers, each carrying up to 20 tons. Upon arrival at the factory, the peanuts undergo initial processing to ensure quality. The facility, often spanning several acres, is equipped with stainless steel machinery and automated systems to handle large volumes. The peanuts are unloaded from trailers into receiving hoppers, which feed them into the cleaning system. This system uses a series of vibrating screens, air blowers, and magnetic separators to remove debris such as stones, sticks, leaves, and metal fragments. The screens are calibrated to allow peanuts to pass through while filtering out larger or smaller contaminants. Air blowers generate wind speeds of up to 50 miles per hour to lift lighter debris away. A typical cleaning line processes 5 to 10 tons of peanuts per hour, ensuring only clean pods move forward. Quality control technicians monitor the process, using sensors to detect foreign materials. This step is essential to meet food safety standards, as even a single stone could damage equipment or contaminate the final product. The cleaned peanuts are then shelled, a process that removes their hard outer shells. Shelling machines use rollers and air pressure to crack the pods, without damaging the nuts inside. The peanuts are fed into the machine at a rate of up to 2 tons per hour, passing through a series of slotted screens. The shells split open, and the nuts fall through, while the shells are conveyed to a separate collection bin. These shells, making up about 20 to 30% of the pod's weight, are repurposed for animal feed, mulch, or even biofuel. The shelled peanuts, now exposed, undergo a visual inspection by workers who remove any defective nuts, such as those that are discolored or undersized. Automated optical sorters, using high-resolution cameras and infrared sensors, can also detect imperfections, rejecting up to 99.9% of substandard nuts. This ensures only high-quality peanuts proceed, maintaining consistency in flavor and texture. Next, the peanuts are blanched to remove their thin reddish-brown skins. Blanching machines use gentle abrasion or air pressure to peel the skins away, processing up to 1 ton per hour. The peanuts are fed into rotating drums lined with soft brushes or pass through air jets that create a vacuum effect, lifting the skins off. The skins, which account for about 3 to 5% of the peanut's weight, are collected via suction and used for compost or animal feed. The blanched peanuts, now smooth and pale, are inspected again, either manually or with automated systems, to ensure no skins remain. This step is crucial, as the skins can add a bitter taste to the final product. Fact: blanching also reduces the risk of aflatoxin, a naturally occurring toxin produced by certain molds, which can contaminate peanuts if not properly processed. The blanched peanuts are then roasted, a step that develops their signature flavor and ensures safety. Roasting occurs in large continuous flow ovens that can process 2 to 5 tons of peanuts per hour. The ovens maintain temperatures between 100 and 180 degrees Celsius, with hot air circulating evenly to roast the peanuts uniformly. The roasting time, typically 15 to 30 minutes, is adjusted based on the desired flavor profile: light, medium, or dark roast. During roasting, the peanuts' natural oils are released, enhancing their nutty aroma and killing off any bacteria or pathogens. The ovens are equipped with cooling zones at the exit, where fans reduce the peanuts' temperature to below 40 degrees Celsius within minutes to prevent overcooking. Quality control systems monitor moisture content, targeting 1 to 2% to ensure a crisp texture. Roasted peanuts are sampled and tested for flavor consistency, with technicians using spectrometers to analyze oil content and color. Now comes the grinding stage, where the roasted peanuts are transformed into peanut butter. High-speed grinders, capable of processing 1 to 3 tons per hour, crush the peanuts into a smooth paste. The machines use stainless steel blades or rollers that rotate at speeds up to 3,000 RPM, generating heat from friction that further releases the peanuts' oils. This creates a creamy base with a fat content of about 50%. Some manufacturers add ingredients like salt, 1 to 2%, sugar, 1 to 5%, or stabilizers like hydrogenated vegetable oil, 0.5 to 2%, to enhance flavor or prevent oil separation. The grinding process is often done in 2 stages: a coarse grind to break the peanuts down, followed by a fine grind to achieve the desired smoothness. The peanut butter flows out of the grinder in a thick, glossy stream, with a viscosity of 200 to 300 centipoise for creamy varieties. Samples are tested for texture using viscometers, ensuring consistency across batches. To achieve the final smooth texture, the peanut butter undergoes homogenization. High-pressure homogenizers, operating at 2,000 to 3,000 psi, force the paste through narrow valves, breaking down any remaining particles and blending the mixture uniformly. This process, which takes just seconds per batch, ensures the peanut butter has a silky consistency and prevents oil separation during storage. The homogenizers can handle up to 5,000 liters per hour, with automated controls maintaining precise pressure levels. Quality checks at this stage include testing for particle size, targeting less than 50 microns for a smooth mouthfeel. The homogenized peanut butter is then cooled to around 30 degrees Celsius, using heat exchangers to prepare it for packaging, maintaining its thick but flowable state. The final stage is packaging, where the peanut butter is filled into jars or containers. Automated filling machines dispense the product into clean, food-grade jars at a rate of 10,000 to 20,000 units per hour. The machines use piston fillers to ensure each jar receives the exact amount, typically 12 to 40 ounces, with an accuracy of plus or minus 0.5 grams. The filled jars move along conveyor belts to capping stations, where lids are applied and sealed using vacuum or pressure systems to ensure airtight closure. Labeling machines then wrap each jar with branded labels, applied at speeds up to 300 jars per minute. The labels include nutritional information, ingredients, and batch codes for traceability. Final inspections check for proper sealing and label alignment, with defective jars removed by automated rejectors. The jars are then packed into cartons, typically 12 to 24 per box, and palletized for distribution. A single factory can produce enough peanut butter to fill over 1 million jars per week. Throughout the process, quality control is paramount. Factories adhere to standards like those set by the FDA or Codex Alimentarius, testing for contaminants like aflatoxin limits below 20 parts per billion, and pathogens like salmonella. Automated sensors monitor every stage, from cleaning to packaging, while workers conduct random sampling. For example, roasted peanuts are tested for moisture and oil content, and finished peanut butter is checked for pH around 6.0 to 6.5 and water activity below 0.6. To ensure shelf stability, energy efficiency is also a focus. With modern factories using up to 30% less electricity than a decade ago, thanks to advanced automation and optimized machinery. The entire process, from field to jar, can take as little as 48 hours, showcasing the efficiency of industrial production. This factory review reveals the precision and scale behind peanut butter production, from harvesting 20 tons of peanuts per trailer to filling 10,000 jars per hour. Every step is optimized for quality and efficiency. The process combines advanced machinery, rigorous quality checks, and a deep understanding of peanut science to deliver a product that's both delicious and safe. If you found this detailed look at peanut butter production fascinating, hit the like button, subscribe, and share your thoughts in the comments. How do you enjoy your peanut butter? Let us know, and stay tuned for more factory process breakdowns.